Hello everybody. This video is going to talk about radical equations. So we have made it through all of the basic operations with radicals, looked at expressions, simplifying, breaking them down. So now it's time to move into solving some equations. So we've got some steps that we're going to follow in general here, and we're going to look at quite a few examples. So the first thing that we want to do is we want to isolate the radical expression. So if you're looking at this example below, the radical would strictly be the fourth root of m here. There's a 3 in front that's a positive. And then technically this is like a -1 that you can think of that's being multiplied by that radical. So to get the radical by itself, we would have to subtract 3 from both sides. Okay, and then to get rid of that negative that's in front, I have to divide by -1. So when I do that, my radical is now isolated. So I get the fourth root of m equals 3. Okay, so we've done the first step there. Okay, now it says we need to raise each side of the equation to the power of the index to eliminate that radical sign. So, back when we were doing quadratics, we said, square roots and exponent of 2, squaring something, they cancel each other out. Well, if I want to cancel this fourth root out, I need to raise it to the fourth power. And if I'm going to do that, I better do it to the other side as well. So when I when I raise the fourth root to the fourth power, it cancels, leaving me with just m. 3 to the fourth power is just 81. So technically, we don't even have to solve anything here. Okay, our equation is solved after we raise each side to the fourth power. Okay, but here's the thing though. It is possible to get extraneous solutions. Remember, extraneous solutions are solutions that you solve and get, but when you plug them back into your original equation, they don't actually satisfy that equation. They're kind of like decoys. So we need to check our work. We need to plug 81 back in and make sure that, this actually checks out. Make sure it works the way we want it to work. Okay, so we know the fourth root of 81 is 3. 3 minus 3 is 0. So it checks out. 81 is an actual solution to this equation. So let's look at another one a little more complicated. So again, we're going to start by isolating our radical. In this case, that just means, we have to subtract 10 from both sides. Okay, so now to cancel out that square root, we have to square each side. So that gives us 6w minus 5 equal to 49. And now we're just solving a basic equation. Let's add 5 to both sides and then divide by 6. So we get w equals 9. But don't forget, we have to plug it back in and make sure it actually works. So we do the square root of 6 times 9 minus 5. We add 10, and we're hoping that equals 3. So let's see. 6 times 9 is 54. Minus 5 is 7. I'm sorry. Jumping ahead of myself here. 54 minus 5 is 49. When we square root in the next step, we're going to get 7. Okay, so 7 plus 10 does not give us 3. Okay, this does not work out, which means that solution of 9 that we found is extraneous. Okay, because that was the only potential solution and it was extraneous, there is no solution to this equation. Now let's backtrack and try to figure out, why did this happen? Maybe you caught it right at the beginning, okay, but right here before we squared each side, I had the square root of 6w minus 5 equal to a -7. Okay, we can't square root something and get a negative number. It's not possible. So that should have been an indicator to you that, hey, maybe something's not going to work out here. Kind of like when we looked at absolute value equations back toward the beginning of the year, we saw, hey, when an absolute value is equal to a negative, you know that it's not going to have a solution. Now, I will warn you that that would not result in a no solution if it was a cube root instead. Okay, remember, we can cube root numbers and get negatives. That's totally fine. We can't with square roots, so you've just got to be careful and pay attention to what kind of root you're taking. All right, let's look at another one. One where we have radicals on both sides. Now, we kind of lucked out here because we have the fourth root on both sides of our equation, so we don't need to isolate anything. We just need to go ahead and raise each side to the fourth power to cancel out those radicals. That leaves us with 27 minus 2d equals d minus 3. I'm going to get my variables to the right side, so I'm going to add 2d to both sides. I'm going to add 3. So we're going to get d equal to 10. So let's just plug it in and, make sure that it works out here. So let's see. We've got the fourth root of 27 minus, well, if I plug in 10, I'm going to get minus 20. And then on the other side here, we get 10 minus 3. So we get the fourth root of 7 equal to the fourth root of 7. So it checks out. 10 is our actual solution to this equation. Okay, let's look at one more here. One where it's going to result in a quadratic, and let's see why. So we need to isolate our radical here. So that means I need to subtract 7a from both sides. So that's going to leave us with 12 minus a equals 1a, or just a. To cancel my square root now, I need to square both sides. And you can see here why I said this is going to become quadratic. Okay, on the left side, squaring that square root cancels it out. I'm left with 12 minus a. On the right side, we created an a squared. We've got a quadratic equation. Let's get everything to one side. I'm going to move it to the right side just so I can keep that a squared positive. I get a squared plus a minus 12. It's a quadratic trinomial. Solving this is probably going to be easiest just by factoring. So you're thinking, what two numbers multiply to negative 12 and add to 1? Well, that would be a positive 4 and a negative 3. So this is going to factor into a plus 4 times a minus 3. We set each of those factors individually to 0. And then we solve. So we're going to get a equals negative 4 and a equals positive 3. Now, we have to check both of these solutions to see if they work. So let's start with the negative 4 here. If I plug in negative 4, I get 12 minus negative 4 plus 7 times negative 4 equals 8 times negative 4. Okay, well, that's going to give me 16 underneath my square root minus 28 equal to negative 32. Okay, if I square root 16, I get 4. Okay, 4 minus 28 is negative 24, which does not equal negative 32. So that tells me negative 4 is an extraneous solution. So I'm just going to cross it out. That doesn't actually work. Let's check 3. So if we plug in 3, we're going to get square root of 12 minus 3 plus 21 equal to 24. Give myself some room here. So let's see, we get the square root of 9 plus 21 equals 24. So 3 plus 21. So this one checks out. When we plug in 3, we get 24 equals 24, which means the only solution to that equation is 3. The negative 4 is extraneous. Just cross it out. If both of these solutions had been extraneous, then we would have said there is no solution. All right, that is it for this video. Let me know if you have questions, and have a great rest of your day.